Welcome back. Today we will be talking about chemistry of carbohydrates. You must be wondering by now, chemistry? Who wants to learn chemistries? I won't be going much into the details of the structures or anything. I'll be just giving you a brief overview what is required to you to be known clinically also for further use or for the sake of the entrance exams. So, what are carbohydrates? You all know that carbohydrates are the main sources of energy for the human body. By definition, how do we define carbohydrates? We say that carbohydrates are polyhydroxy, aldehydes or ketones. That means they all will have an aldehyde group and or a keto group. So any compound which has an aldehyde group or a keto group come under the class of carbohydrates. So basically all carbohydrates are polyhydroxy, aldehydes or ketoses or compounds which give these upon hydrolysis. All carbohydrates can also be represented as hydrates of carbon. That means hydrates, CH2O, hydrates of carbon in a n number of times. So C6H12O6 or something like that. They are all hydrates of carbons. Now I won't go much into the details of all the carbohydrates. What I'll be focusing on right now is on the classification of carbohydrates and certain properties of especially the monosaccharides. Now if you look at the classification, all carbohydrates can be classified into all the carbohydrates which come under are hydrates of carbon can be classified into monosaccharides. That means they have a single unit of sugar, or they can be disaccharides. That is, they are made up of two monosaccharide units, or they can be oligosaccharides. That means more than 2, less than 10, or they may be polysaccharides. That means more than 10 sugar units in each residue. These are the main basic classification of carbohydrates. Now I'll be dealing in today's session, I'll be dealing more about monosaccharides and their properties. So now we go on to monosaccharides. What are monosaccharides? Monosaccharides are compounds which are molecules which have one potential or actual sugar group. Now these monosaccharides are further depending upon the functional group. They may be classified into aldoses or ketoses. Remember that all carbohydrates usually end in the word OSES. This is the way classically there have been the nomenclature of carbohydrates, aldoses or ketoses, depending upon the aldehyde group or the keto group. Again, these monosaccharides can also be classified based on the number of carbon atoms. How many atoms does each molecule contain? So if it has 3 molecules, we call it a triose. If it has 4 molecules, we call it a tetrose. Now here I am having a table. We will have a look at the table which tells you which are the different types of monosaccharides that can be there. Now we will look at the number of carbon atoms. If there are 3, you call it a triose. The aldose sugar is glyceraldehyde and the keto sugar is dihydroxyacetone. If it is 4, you call it a tetrose. It is erythrose and erythrulose. If it is 5 carbon atom, you call it a pentose, ribose, ribulose. Hexose, you have got many examples like glucose, galactose, mannose. Ketose like fructose. Heptose like glucoheptose and pseudoheptulose. These are the different monosaccharides that are present, biologically important, and we need to know about them. As I said, I'll be talking mainly about monosaccharides now. I'll be talking few more about certain isomerisms that are found in monosaccharides. Why is an isomer formed? What do you mean by an isomer? An isomer is a substance which are molecules which have the same chemical formula but differ in their with different other properties like especially the arrangement of groups around the carbon atoms. Now, which are the different types of isomerism that are present in monosaccharides? Basically, we have firstly the functional isomerism. So, they all may be having the same chemical composition, but suppose they have the aldehyde group, it becomes a aldose. They have the keto group, it becomes a ketose. This is known as a functional isomerism. That means the functional group is different. Now, the other type of isomerism that can be seen in monosaccharide is stereoisomerism. What do you mean by stereo? Stereo means position. So, in stereoisomerism, it all depends upon the position of groups around the carbon atom. I'll be talking more about this. Other type of isomerism that is possible in monosaccharides is what is called as optical isomerism. Optical isomerism basically is a way by which we can see whether a solution of monosaccharide, it will rotate a plane polarized light to the right or to the left. So depending on that, we have different optical isomers that are possible. Now, focus will be on stereoisomerism. What is stereo? As I said, it depends on the place. So, depending upon the position of different groups around the carbon atom, we will have different stereoisomerism. Now, is it possible that it can be around all the carbon atoms? Usually no. We say that stereoisomerism is possible only and only if the carbon atom is an asymmetric carbon atom. So, isomerism is possible whenever the carbon atom is asymmetric. What do I mean when I say asymmetric? It means a carbon atom which is attached to 4 different groups. So whenever a carbon atom is attached to 4 different groups, it can result in the formation of stereoisomers. So how many isomers are possible? It all depends upon the number of asymmetric carbon atoms. Suppose a molecule is having 4 asymmetric carbon atoms, then 2 to the power of n, that is 2 to the power of 4 is the number of isomers that are possible. Now, out of all the stereoisomerism, what we'll be focusing, what is required to be known are 3 main isomerism, and that is, I just write it down here, in this only, the properties of monosaccharides. 3 main things that we'll be looking at. One is the D and L isomerism. The second thing that we'll be looking at is what are epimers. This is all important to you when we look at MCQs. So D and L isomers, the epimers and the anomers. What are these? What do they exactly mean? That is all we will look at. Now, D and L isomers are nothing but enantiomers. What do you mean by enantiomers? Enantiomers means they are mirror images of each other. Suppose you have a right hand and a left hand. These are mirror images of each other. So the molecules which are mirror images of each other are called as enantiomers. So one is called as the D isomer, the other is called as the L isomer. It all depends upon, by default, by people, scientists who have already told that what is called as an L isomer, which group will constitutes the D isomer. It all depends upon the position of certain groups around the penultimate carbon atom. Now, you need not go so much into the details of it. What is important is D and L isomers are designated, are mirror images of each other, and the position of the H and OH group around the penultimate carbon atom. So, if the OH group is on the right side, as you can see here, we call it the D isomer, and if the OH group is on the left side, we call it the L isomer. What is the importance of this? There are certain enzymes called as racinases which can interconvert between D and L groups. And the second important thing is all naturally occurring sugars are all D sugars. The body can metabolize only the D isomer. So that is the reason why we have to know about D and L enantiomers. Now we go further. As I said, the next type of isomerism that is possible is epimers. So what is this epimers? when two monosaccharides differ from each other in the configuration around a single carbon atom, no other carbon atom, only around a single, only one carbon atom, only then we call them as epimers. So what about D and L? Don't they differ under a single carbon atom? So other than the D and L carbon atom, if they differ around a single carbon atom, then we call them as epimers. For example, why do we need to know this? Example is, we can see here, glucose and galactose are epimers of each other. But to be more specific, D-glucose and D-galactose are epimers of each other, whereas D-glucose and L-galactose are not epimers of each other. So the importance here is they differ around a single carbon atom. Now glucose and galactose are C4 epimers. So this is where the whole thing gets confusing for many people. So C4, C2, which is that? We usually write G as like this. So if you look at it, it looks somewhat like 4. So glucose and galactose are C4 epimers. So that is why, that's a way you can remember between which carbon atom they are the epimers of. D-glucose and D-mannose are C2 epimers. So around only the C2, they differ in the configuration of H and OH atoms. Why this is important? Again, in the body, we have enzymes known as epimerases, which they are process by which one glucose or galactose are interconverted is known as epimerization, and the enzyme is epimerase. So that is the reason why you have to know about it. Now we go on to the other isomerism that is possible in monosaccharide, and that is anomers. Now what is this anomers? Anomers is possible only when a monosaccharide assumes a ring structure, a cyclic structure. If it's then what's the difference between an open chain and cyclic? Usually in solutions, glucose, instead of just being in the straight chain, forms a cycle. When it forms a cycle, a previously symmetrical carbon atom gets converted to asymmetrical carbon atom. So this anomerism was able to explain certain properties of glucose, and they found out that glucose in solution exists as a cycle form, as a ring form, and that is when we get the two different anomers of glucose or any other monosaccharide. So in solution, glucose forms a ring structure. A previously symmetrical carbon atom is converted into an asymmetric carbon atom. This carbon atom is now called the anomeric carbon. This results in the formation of two isomeric forms, which are called anomers. And the anomers are alpha and beta anomers. Again, why do we need to know it? Both this is important because when we come to lab diagnosis or when we come within the body, the alpha anomer or the beta anomer, this can change. So that is the reason why we have to know about the two isomeric or anomers of glucose. Anomers have different physical properties, they have different chemical properties, and enzymes are also specific for the particular anomeric form. Now, why do I need to know it? If you look at glycogen, glycogen is synthesized exclusively from alpha D glucose, whereas cellulose is synthesized exclusively from beta D glucose. So that is the reason why we have to know about anomerism. Now, as I said, there is one more type of isomerism that is possible, and that is optical isomerism. It is also because of the asymmetric carbon atom. We have two types in that, dextrorotatory and levorotatory, and usually this is expressed as plus or minus. D minus, D plus or small d is how it is represented as. And why we need to know it is glucose is dextrorotatory, hence it is called as dextrose. The name dextrose for glucose has come because it is dextrorotatory. A racemic mixture is an equimolecular mixture of optical isomers, and there is no net rotation, and optical activity is usually measured using a polarimeter. Now, there is another phenomenon that is somewhat important, and that is mutarotation. I'll just briefly tell about it. The change in the specific rotation with time is called as mutarotation. This is because of conversion between alpha and beta forms. At equilibrium, 1/3 or 36% of the molecules are in alpha form and 63% are in beta form, and 1% is in open chain conformation. So that is regarding the isomerism that is possible in monosaccharides. We go ahead with some biologically important monosaccharides. I just want you to look at this table. Important monosaccharides. Ribose is a pentose which is present in RNA. Is it only in RNA? Deoxyribose is a pentose which is present in DNA. Glucose is the main sugar of the blood. Fructose or levulose, because it is called as levulose because it is levolotatory, is the sugar which is present in fruits and semen. Galactose is present in milk sugar lactose. Mannose enters in the composition of mucopolysaccharides. This is regarding the isomerism in monosaccharides. I'll go further. Briefly about some properties of monosaccharides. Certain properties which are important for us, which help in the actual knowing about the different monosaccharides. Now, one important property that is important always is what is called as the enediol formation and the reducing property of glucose. I have got something out here which tells you glucose, always in alkaline solution, undergoes tautomerization to form fructose and mannose with the formation of an intermediate enediol. So I'll just show you how it happens. Fructose, glucose, mannose, all three of them are interconvertible. So glucose can be converted to fructose, glucose can be converted to mannose, and vice versa, with the formation of an intermediate enediol. What is this enediol? It has got a double bond with two hydroxyl groups around the carbon. We need not go into the chemistry of it. What is important is the reducing property of all the reducing sugar is because of this enediols. Enediols are highly reactive and they can easily donate hydrogen atoms or electrons and act as reducing agent. So this is when it gets reduced, enediol or a sugar acts as a reducing agent and sugar gets converted to sugar acid. So what does it reduce? It can give its electrons to different reducing agents like the Benedict's agent, which we all know about, the Benedict's reagent. So when it can reduce the Benedict's reagent, it will reduce it and it will result in the formation of a colored compound. So this is important property, reducing property of glucose. Only sugars with free oxygen at the anomeric carbon atom can act as a reducing agent. That is important here. Now the different tests, not only Benedict's test, you have the Barforth's test, the Fehling's test, the Follinwood test, all of which different tests are all basically based on the reducing property of monosaccharide. Now we go on to another important property of monosaccharide, and that is oxidation of the monosaccharide. So the glucose or any of the monosaccharide can be oxidized. So when it gets oxidized, it forms sugar acids. So which are the different types of sugar acids that can be formed? If the oxidation occurs at the aldehyde group, we get the aldonic acids. Example, glucose is converted to gluconic acid, mannose is converted to mannoic acid. If the oxidation occurs of the terminal alcohol group, we get uronic acid. Example, glucose is converted to glucuronic acid, mannose to mannuronic acid. And oxidation of both the aldehyde and the alcohol group results in the formation of saccharic acid. Glucosaccharic acid, galactose will form mucic acid. What is the importance of all this? I think you all have heard about glucuronic acid. Glucuronic acid is a conjugating agent. If you have known about bilirubin gets conjugated with glucuronic acid, and this is a process by which bilirubin gets detoxified. So that is the reason why we want to know about sugar acids. Now another important property of monosaccharides is the formation of its alcohol. That is, aldoses produce a single alcohol and keto sugars form two alcohol derivatives. Example, glucose can be converted to sorbitol, galactose can be converted to dulcitol, mannose can be converted to mannitol. Where have you heard of this? Sorbitol is what accumulates in the lens of the eye. Sorbitol is the one which is responsible for diabetic cataract. Mannitol is used in the hospitals to decrease the intracranial pressure is decreased because of mannitol. Ribose forms ribitol, fructose forms sorbitol and mannitol. These are the different alcoholic properties of monosaccharide. Now another thing that can happen is the oxygen can be removed from the hydroxyl group. It will result in the formation of a deoxy compound. For example, ribose is converted to deoxyribose. It is present in the DNA. And there are specific stains which are responsible for staining the deoxyribose, and that is how we can identify DNA in different stains. A little bit about the formation of amino sugars. So all these monosaccharides can be aminated, can be substituted with an amino group, and like glucosamine, galactosamine. Why am I talking about this? I'll be talking in detail about this we need to know about the heteropolysaccharides. The amino groups also can be further acetylated to form the N-acetylated compounds. N-acetylglucosamine, galactosamine. Please look at here. Glucose, which has got an amine derivative and which has been acetylated. This is a simple way of the property of monosaccharides. They are all the components of glycoproteins and cell membrane antigens. So the carbohydrates can also combine with different non-carbohydrate or carbohydrate compounds, and the bond is called as glycosidic, and this can be called as N-glycosidic or O-glycosidic bond. I'll deal with it more as we talk about different glycosides. Okay, one important thing is the carbohydrate has the non-carbohydrate compound with which it forms a bond is called as aglycone. The nomenclature is also specific. I'll be dealing with it further as we talk about different disaccharides that are formed. To summarize, the different properties of monosaccharides are the enediol or the reducing property. Sugars, monosaccharides can form sugar acids like glucuronic acid, which is important. They can form alcohols like glucose can be converted to sorbitol. They can form deoxy sugars, for example deoxyribose, which is present in DNA. They can form amino sugars which are present in heteropolysaccharides. They can form glycosides with different compounds. Thank you.